I had this moment the other day, and I think everyone listening has probably had it too. I was using ChatGPT, just watching the words stream out one after another. And for a second, I totally forgot it was a machine. It really feels like there's a brain on the other side thinking.
It's an incredibly powerful illusion. I mean, it's designed to feel exactly like that.
Right. But then I remembered let's call it the dirty secret of AI that we talk about all the time. It isn't thinking.
Yeah.
It's just predicting. It's the world's most sophisticated autocomplete.
That is the harsh reality. What you're watching is an autoregressive model, or ARM. It reads what you wrote, it calculates the statistical probability of the next word, picks one, and then it just does that again and again.
A straight line.
Purely linear, strictly left to right.
And that has been the gospel for years. That's just how AI works. You want a smarter AI, you just build a bigger autocomplete. But today, well, we're looking at a research paper that suggests that might not be the only way.
And if these researchers are right, it might not even be the best way.
Now, that is a massive claim. We're basically questioning the fundamental architecture of this whole generative AI boom.
We are. We're doing a deep dive into a paper from Renmin University of China and the Ant Group. They've built a new model they're calling LLaDA.
LLaDA? LLaDA?
Right. It stands for Large Language Diffusion with Masking.
Okay, LLaDA. And the whole idea here is it's a what-if question that sounds a little bit sci-fi. What if an AI didn't have to write from left to right?
Yeah.
What if it could see the whole sentence, the beginning, the middle, the end all at once?
It's a total architectural shift. If a standard LLM is like a bricklayer, placing one brick at a time and only looking at what they just built,
Okay.
then LLaDA is more like a painter. It sketches the whole image on the canvas at once, very roughly at first, and then it goes back and sharpens the details across the entire thing until the picture is clear.
That's a really good analogy, but I want to get specific here because my brain is trying to wrap around this.
Yeah.
Diffusion is a word I associate with image generators. Midjourney, DLE, that sort of thing.
Right.
You start with static, with noise, and it becomes a picture. How on earth do you apply that to text? You can't have a noisy word. A word is either there or it isn't.
That's the big hurdle. You're exactly right. In images, you have pixels, and you can have a pixel that's sort of halfway between blue and green. It's fuzzy.
But you can't have a word that's halfway between cat and dog.
Exactly. So instead of visual noise, LLaDA uses something called masking.
Masking. Okay, so walk me through this. How does masking replace the static?
So imagine you have a perfect sentence. Let's use the classic. The quick brown fox jumps over the lazy dog. To train the model in what they call the forward process, the system just starts randomly erasing words.
Erasing them.
It replaces them with a special token, literally a mask token. So you might get the quick mask, fox jumps mask, the lazy dog. And it keeps doing that, more and more masks, until at the extreme end, you're just left with a string of 9 mask tokens. It's a blank slate.
So you're basically destroying information. You're turning a sentence into nothing?
Precisely. You're turning order into chaos. But then comes the really clever part. The reverse process. The model is given that string of empty masks and is basically told, turn this back into a sentence.
But how? If it's just blank slots, it could be any sentence in the world. How does it know where to even begin?
Well, that's where the diffusion part comes in. It doesn't guess the perfect sentence in one shot. It makes a hazy first guess. It fills in all the masks at the same time with what it thinks might be there.
So it throws some paint at the canvas.
Right. And maybe it gets a few words right, like boo at the beginning and dog at the end, but the middle is just total gibberish. Then it looks at its own work, that mix of words and masks, and it refines it.
It edits itself?
Yes. It says, okay, the dog and dog look pretty good. I'm confident about those. But this middle part doesn't make any sense. So it remasks the bad parts and tries again. And it does this over and over, stepping its way from pure noise to a coherent thought.
So unlike a GPT-4, which commits to word number 1, then commits to word number 2, LLaDA it's drafting. It's writing a rough draft and then editing it in real time.
That's a perfect way to put it. It's refining a thought, not just stringing it together linearly.
Which, honestly, sounds a lot more human. When I'm writing, I don't always start with the first sentence. Sometimes I write the main point first, and then I go back and do the intro.
You're accessing the information bidirectionally. You're using the end of your thought to inform the beginning. Standard LLMs strictly cannot do that. They have what's called a causal mask, which is just a technical way of saying they're blind to the future.
They can only look backwards.
Aggressively so.
Okay, conceptually, this is fascinating. But I have to ask, usually when we see these alternate architectures, they're kind of toys. Cool little experiments that can write a haiku but fall apart if you ask them a real question.
Mm.
Is LLaDA a serious model?
This is definitely not a toy. The researchers trained LLaDA 8B, that's an 8 billion parameter model, completely from scratch.
From scratch? Wow, that's not cheap. That takes some serious compute.
It does. They used a data set of 2.3 trillion tokens.
2.3 trillion. What's in that data pile? Is it just the standard stuff?
It's a very deliberate mix. You've got your web text, books, Wikipedia, the usual diet. But what's really interesting is that 28% of the data is code.
Almost a third of it is code. Why so much?
It's deeper than just teaching it to help developers. Code teaches structure. In programming, the closing bracket at the end of a file is just as important as the function you defined at the top. It forces the model to understand these long-range dependencies.
The relationship between the beginning and the end.
Exactly. They also threw in a lot of math data for the same reason. It's all about teaching logic and structure, not just prose. And there's about 11% Chinese data in there, too, which makes sense given the research team.
Okay, so a serious model. Massive data, this new diffusion technique. Now, I want to go back to something you said about the model being blind to the future. The paper has this great name for it, the reversal curse.
Ah, yes, the reversal curse. This is the ultimate gotcha for standard LLMs. It's the test that really exposes the weakness of that bricklayer approach.
It sounds like a horror movie title.
It's just as mysterious to most people. Basically, if an autoregressive model learns that A is B, it often completely fails to understand that B is A.
Wait, that seems incredibly basic. If I tell you my car is a Ford, you automatically know Ford is the make of my car. It's the same piece of information.
You do, because you have a world model in your head, you understand the relationship, but a standard LLM just stores that as a one-way sequence of probabilities. My predicts car predicts is, and so on.
It's a one-way street, so if you try to go the wrong way,
You crash, and the paper uses this fantastic example to prove it. Poetry.
I saw this, the poem completion task.
Right. So if you take GPT-4o, which is arguably the most powerful model on the planet, and you give it the first line of a famous poem, it will instantly give you the second line. Perfect memory.
Easy.
But if you give it the second line and ask, what was the line before this? It just falls apart.
It can't recite the poem backwards.
It's shockingly bad at it because its entire internal map only points forward. It literally cannot think backward to retrieve the start of the sequence it knows so well.
Okay, so this was the showdown. LLaDA versus GPT-4o.
It was. On this reversal task, GPT-4o scored about 34.3%, which, for a model that smart, is basically a failing grade.
And LLaDA.
LLaDA 8B, and remember, this is a much, much smaller model than GPT-4o scored 45.6%.
It beat the heavyweight champion.
By a huge margin. And it's because LLaDA doesn't care about forward or backward. To LLaDA, predicting the first word from the last is the same exact mechanism as predicting the last from the first. It's just filling in a blank.
That is a massive insight. It suggests that some of the stupidity we see in AI, the hallucinations, losing the plot.
Yeah.
It might not be a size problem. It might be an architecture problem.
Precisely. We've been trying to solve it by just making the bricklayer bigger and faster. LLaDA suggests we should have been hiring a painter all along.
Okay, but let's play devil's advocate. Being able to recite poetry backwards is a cool party trick. But does that actually translate to useful work? Can this thing do math? Can it code? Or is it a one-trick pony?
That's the scalability question, and it's the first thing they checked. They wanted to see if LLaDA actually follows the scaling laws.
Meaning, if you give it more power, does it actually get smarter in a predictable way?
And the answer is a clear yes. It scales just like a standard LLM. This architecture isn't a dead end.
They compared it against Llama 3, right, which is pretty much the gold standard for open source models of that size.
Correct. Specifically the 8 billion parameter version. In zero-shot tasks, where you just ask it a question cold, LLaDA was right there, neck and neck with Llama 3. And it beat the last generation, Llama 2, on almost everything.
And what about the hard stuff, the logic?
It held its own. On the GSM-8K math benchmark and the human evil coding benchmark, it showed really strong performance.
That's surprising to me. I always thought diffusion models, because they deal with this fuzziness, would struggle with precise logic. I thought they were for art, not algebra.
That was the assumption. But this paper really proves that with the right data, remember that 28% code, you can teach a diffusion model to be just as precise.
And they didn't just stop there. They fine-tuned it.
Right.
To turn it from a text completer into an actual chatbot.
Right. They created LLaDA Instruct by training it on 4.5 million instruction pairs. Now it can hold a conversation, remember context. It can act like the assistants we're all used to.
Okay, so it works, it's smart, it scales, it can do logic. But I want to go back to the user experience. You said it refines the text. If I'm using it, does the answer just pop out fully formed?
This brings us to probably the most interesting trade-off of the model, and it's something that actually gives power back to you, the user. It's all about the sampling strategy.
Okay, break that down.
So with a normal model, you get one word at a time. The speed is basically constant. With LLaDA, you get to decide how many refinement steps you want it to take.
I can tell it to think longer.
In effect, yes. They use this really clever technique called low confidence remasking.
I loved this part of the paper. It felt so intuitive.
It is. Imagine you're taking a test. You quickly jot down answers for all 10 questions. Then you go back and look. You say, okay, I'm 100% sure about questions 1 to 5, but 6 is a bit shaky, and I totally guessed on 9.
So you erase 6 and 9 and try again.
Exactly.
Yeah.
You remask the low confidence answers, but you keep the ones you're sure about. Then you ask the model to fill in just those blanks again, using your good answers as the new context.
That's brilliant. It's checking its own work and iterating.
And here's the kicker. You, the user, can control this. If you just want a quick answer, you can tell LLaDA, give me your best shot in just 5 steps. It'll be really fast, but maybe a little rough.
But if I'm asking it to write, say, a legal contract where one mistake is a disaster,
You tell it, take 100 steps. Refine this until you are absolutely certain. It will be much slower, but the precision goes way up.
that's a control knob we just don't have right now. With GPT, I get what I get. I can't tell it to spend an extra 10 seconds making sure it didn't hallucinate.
We're starting to see hints of it, but LLaDA bakes it into the core generation process itself. It's a real-time slider between speed and quality.
This all sounds, frankly, it sounds superior in a lot of ways. It fixes the reversal curse. It gives the user more control. It has a more holistic understanding of context. So why aren't we all switching to this tomorrow? What's the catch?
The catch, as it so often is efficiency. There's a reason the bricklayer model is so popular. It's incredibly efficient to run.
So LLaDA is a bit of a gas guzzler.
It is. Standard LLMs use a very clever trick called a KV cache.
We hear that term a lot. KV cache. What is it, in simple terms?
Think of it like a cheat sheet. When an autoregressive model is generating word number 50, it doesn't have to reread and recalculate the first 49 words. It has all the important calculations for those words stored in this cache, this memory. It only has to do the math for the new word.
So it never repeats its work.
Never. LLaDA, on the other hand, is potentially changing the entire sentence at every single step. It can't easily cache the past, because the past might change in the next refinement.
Oh, right. If it realizes word number 5 was wrong, it's going to change it.
And that breaks the whole caching system. So
Yeah.
at every single step of refinement, it has to reprocess the entire sequence from scratch.
Ouch. So if I ask for a 50-step refinement, it's doing the work of reading the whole sentence 50 times over.
Roughly speaking, yes. And that makes it computationally heavy. It's slower and more expensive to run than a standard model of the same size.
That is a major bottleneck.
There's one other thing, too, the issue of length. Because you start with a set number of masks.
You have to know how long you want the answer to be before you start.
Sort of. With ChatGPT, you can just let it ramble on. With LLaDA, you have to hand it a canvas of a specific size and say, fill these 500 slots. The paper says it's not super sensitive to this. It can use end-of-sentence tokens to stop early, but it is a constraint you have to think about up front.
So we probably aren't going to see LLaDA powering our favorite chatbots next week.
Not next week, no. But I wouldn't bet against this approach in the long run. If they can solve the speed problem, and they're already working on it.
Then you have a model that's just as fast, but fundamentally smarter about planning and structure.
Exactly. And even now, think about the applications where speed isn't the top priority, but accuracy is everything.
Legal contracts, like I said.
Yeah.
Or designing complex code.
Or scientific research, logistical planning, anywhere you need to see the end of the problem to understand how to start it. If you're designing a building, you need to know what the roof looks like to know how thick the foundation should be. LLaDA thinks like an architect. GPT thinks like a bricklayer.
And that feels like the real key takeaway for me. This paper proves that next token prediction, the thing we all just accepted as the definition of AI, is just one option. It's not the only way to get to intelligence.
It breaks the monopoly. It shows that abilities like instruction following and reasoning aren't just some magic side effect of predicting the next word. They're fundamental properties of generative modeling itself. You can get there with bricks or you can get there with paint.
It validates the science of AI beyond just one specific engineering trick.
And it brings diffusion, which has already completely transformed images, video, and audio right to the final frontier text.
It's fascinating. And I want to leave everyone listening with one final thought to mull over. We talked about how LLaDA can see the future of the sentence it's writing.
Right?
Well, think about your own brain. When you're solving a really difficult problem, a logic puzzle, a complex argument, do you really think one word at a time? Or do you get that flash of insight where you see the whole solution at once, and then the hard part is just finding the right words to explain it?
That is the ultimate question, isn't it? Are we trying to build a machine that's just really good at guessing the next syllable? Or are we trying to build one that can actually hold a complete thought?
And if LLaDA is the first real step towards that complete thought architecture, then the ceiling for what AI can do just got a whole lot higher.
I couldn't agree more.